Good evening, everyone. Class hours ko koi kanoni thermal properties of matter how doing asi degi ko ado sir na nahan aina taudaba haidi aina taken haigi bido takon ng audaba ko machet amani adu tawraga tawsi ko to the thermal properties of matter how zalasi. So okay, fine, let's start today's class. Now before that in last class ito gida aina last class the semdong nga mapami awuni surface energy ki sigi si ko noi kena to hu brusher na si da error macha am ka yaure error macha ji ken habda si da ina tu na lai si soi bane ba ko ai di bapu oirudre noi khangbra si gi ja tu na lai si ya de ba ko si tu ji yauroi ba ado kamaina wina tawni ha matam da sir hairke ko since f is equal to hairaga have the total f haitare ko f se f is equal to f1 plus f2 and f1 is equal to f2 is equal to sl nebo yabra sisidi yai ko kai no surface tension have do f by l ni dana ko adugi f by l do si se som side to f ama makha lom side ke f ama na f1 plus f2 do adu keno nga to oibagi koina 2f oibagi 2sl lakpo ko yarbo
yarni sir
yarni ko okay fine so sunandaga lakshmi ga ju yarbo ni kumakte
oh sir
yare ko
sir
na yare ko saila yare ko
yare sir
okay fine yare so ngasi gi class ki no wo ka no file am hangasi sinthoi yare ko sinthoi yarni ko okay fine now kido si have the sir na kido kaino yes sir na test hangi ba question ne ba ko Reynolds number na ko Reynolds number so Reynolds number si kaino ay matamda kuina magi kaino leijay ko Reynolds number gi ko masagi formula leijay my symbol do re oibra rz oibra I think it's re ko nagi like the yaw ne ba ko so magi si kayo have the rho kaidoba rho le ko v d by kaidoba coefficient of viscosity oidine ba ko eta oidine ba rho v d by coefficient of viscosity now c sir na last ko again c the okay fine rho di kaino si se rho di density ko density of the fluid haita fluid to gi density oidine and I think it's yad ra simangan gari ko adagi kaidoba v lere ko v sina velocity lere velocity lere d sina kai lere d sina kaidoba d sina diameter ko adumaina leigadoine ba ko so koina sigi sida kai lei ha matamda rho ko rho lere v lere d lere aduga d si keno nen lorse distance nen lorse yai ko precisa ita vd ko yai aduga distance between the two adum diameter lor diameter eta sina kaino eta sina coefficient of viscosity ne ba koina do si sida kaidoba yai ha matamda ne sumaina thamba yabra yam ko eta ko e am hapena ko then eta a kaidoba v by d ire na ko sida na rho lere a yaudamnina sida a am hapani ko makada v am hapadi mathakta v square lerani v square ko sumai lerani adur di ccd kaino da rho a v square di kaino ccd inertial force ne ba ko inertial force and makagi sina kaino eta a v by d sina kaino sisina viscous force So force ngatani na we have the Reynold number say dimensionless number ne because dimensionless constant ne na hiding it. Now C sina kamai to orga the rho a v square sina inertial force kamai oirino and then eta a v by d sina viscous force kamai oirino si khangbra. No response.
Inertial force or the
Nate jigido khang hero khang de hero
khangde haba sir.
khang de ko inertial force is the khang de ko aduga makhagi si di khangbra eta a keno do buze v by d si di khangbra
Asibi viscous.
asibudi viscous force ne ko dv by dz to budu ko adain torga now sigi sida koina kido we have the ko sisi mayare ko audagi sigi first step sida second step sida is khangbra mem lene mak respond to octre kanamta
Khangdisha.
sigi first step sida nangna v ze adi makada bm hapali matakta zu b hapam square tore d je makagi makada puthare matak aiji makagi makani ko a am yam da ji yare ko now haziki noina inertial force khangde habado inertial force si kamaina oino sa hairke ba ko kuina ke we have the rule ere ko area zida aina kayumba the velocity sida gain length ma pu matam da distance ma pu matam da kai dauni the area into distance kind of volume ne ba so density into volume di kind of mass na tra aduga distance ama ka ngayore time square ni so distance by time square di kind of acceleration na tra auna mg gi form the labra hadi sorry ma gi form the labra like so ma the mass into acceleration gi form the lay so ma gi form the lay di kind of force na tra
Mani.
mani ko so inertial force to you ne ba ko aduin toraga aduna rho a v square sa inertial force ni aduga eta a v upon d sina viscous force ne ba so mind to ko ina Reynold number si dimensionless constant en jo high vi aduga si sida noina khangadaba amna khwaide maru orisi kaina the Reynold number si 200 tagi p gai ma si streamline oi gadoine ba ko do we have the if re is less than 200 or 2000 I think it's 2000 ka is less than or equal to 2000 then what the flow is then the flow is streamline ka doin le ni aduga if r is it is if it lies between if if re lies between 2000 and 3000 then the flow then the flow is disturb and no that's not turbulent we're gonna 3000 they chow with the car and unbalanced have the fazade this unsteady hai the unsteady and hag unsteady ka and then if if Reynold number say magi corresponding Reynold number to greater than or equal to 3000 or then the flow is turbulent then the flow is turbulent now sir unsteady streamline turbulent have the streamline hargadi yamna kahne smooth oina flow to budu streamline ka we unsteady hargana streamline smooth oibedo tapna flow to buduga tapna oidrusi ai ka bus haidi mado turbulent turbulence oidaba streamline oidaba do unsteady ko ka marakta leidun have the streamline de jo kitang kangkhatpa flow je aduga turbulent nuksi yodaba aduga turbulent ai na aduki matik kanman gidana maji pochi ke we have the my flow do adudu keno tawtraba hai tare streamline oiba ngamdraba habdi naishalla flow to budu ko aduna adi for example water gi river water na flow to matam da nongju tha gumba yorak tringai gi hadi ko ising ji kedo we have nongju tha matam na to matam da ising ji am na streamline the flow to gal le ko river da cheli je and then heavy downpour heavy rain gumba tho matung da di nongju tha dai kedo wi turbulent the flow to gal le ba ising je ko habdi volume ju myam yami ado volume yam ba khatangi wari na te ko kaido we have the my velocity su yang volume ji yame adu ising ji yam kaido we have the yam kanna flow to tharapagi national la flow to budo ko irai ma yaw flow to budo aduna irai ma yaw flow to budo turbulent ko we ko and turbulent flow di kaido we have the kaino to we ko kani noina again noina fanam swimming hairaga ju iroi be hairaga ju turbulence di yade ko ide koina swim to na fanam honor ju ngam moy ko even kaino manung da leiba aquatic haitare ko animals haitare ising manung da leiba nga oigera any jiba oigera turbulent flow da di moibo swim to ngam de si ni ko nganu de am higraba dubo wa turbulent flow da thadara ga di ma ju dum si ni ba iroi be yara oi du ni ko adumai to dana aeroplane paiba matam da su aeroplane na pairi si cyclone la ga di aeroplane paiba ya deba kaino di aeroplane lift generate to is kaino da neba streamline flow da neba ko ado kayumba turbulent oiragadi my lift to mathak generate to mota magi velocity to gyan men ta da gai nakan dong yang chalakani mathak tong yang chalakani no pot to ching thie ga ne force to mathak to lift mathak to khatang kak leigado force to gyan men ta da gai la ni force gyan ta bra dun aeroplane du kai ni hai ta ko pokhai ba blast to khot pa na in to nei do so Reynold number aduki matik maru iba number ni ko sida based to question amma hangi bane da ki test khangawi ko mya
Sir, coming off.
thermal properties of meteors. Okay, fine. Thermal properties of matter. Now, thermal properties of matter is the kuina tawadu si kaino kakin have thermal properties of matter is can oi duni ko chapter 9 oi dira 9 or maleka.
Chapter 10.
Okay, chapter number 10 la. Okay, fine. Ka chapter number 10 thermal properties of matter. Yare ka. Now, sigisida kuina quite first the coefficient of thermal expansion hana tawzi ka. Coefficient of thermal expansion. Yeah, so coefficient of thermal expansion is in chingi line guys line matak to paigat program to so mine ching na ka fara sina paidara ira kam man chumi na to khanre osi kisi na chum din na sai ji paigat line ka okay fine yeah okay now so coefficient of thermal expansion is kaino have do sir torque ka quite first the linear expansion gi the coefficient of linear expansion and like ni ka so linear expansion han yeng si linear expansion sida kaino koina tawdu je ha matam da nangna kedawi have the ka pod amaze you have suppose you have a rod of length L. Now, C rod chinang na hit to matam da kaidora kani have the mazi on strain ama develop to kani gan dai ko strain ama develop to pa di mazi originally length L sangam mane ba the hit to matam da L plus delta L sang kani ba awna C gi delta L upon L sa it is directly proportional to C directly proportional hai ni ka it is directly proportional to kaidova delta T ne ba have the delta T have the kaino it is directly proportional to temperature height that change in temperature have the nang temperature kam increase together ko aduna pot nang heat to matam da pot amaji my temperature hingat matam maji expand taweba now expansion ji sir lengthwise katang tawbra atai mawong dai tawdabra volumetrically or area magi apakpagumba hengatra loi hengale, but let's first akoina quite first linear expansion katang hana consider to we save ko coefficient of thermal expansion je ahum lay ama ni ahum lay ko quite first ki the number 1 the linear ko mathang da area wise areal hertzian and third the volume or volumetric layer ne ko. So number 1 ki linear expansion is lere adu ergadi na sida delta L by L is equal to harga alpha L delta T. So mine lay gitu ini buka. So that's the first one. Now second one the area ka. Areal expansion harga ka. Area wise hai. Now some analysis we have the delta A by A is directly proportional to delta T. It implies delta A by A is equal to alpha A delta T ka. Now what is this alpha L? The alpha L is known as coefficient of linear expansion coefficient the my constant coefficient of CIENT spelling ng CIENT coefficient of linear expansion. And here sigisidana alpha A ka sidana coefficient of areal expansion ka. Areal expansion and ni buka. And then last ki third subusidana is properly chingle lines ka duna hena ani. Ahum subusidana kedoba third na volumetric expansion. Volumetric expansion. Volumetric expansion we have the delta V by original volume is directly again is equal to the directly proportional is half the half is proportional to delta T change in temperature. So delta V by V is equal to alpha B delta T. And here this alpha V is known as coefficient of volumetric expansion. So expansion now relationship relationship between this one alpha L ka alpha A and alpha V ahumzi. So that's very important. Now let's find out relation between alpha L, alpha A and alpha V okay, fine. Now sir we have the delta L say we have the DL and delta T DT Yandai ka. Aduergadi aina we have the aduga dA by A is equal to alpha L dt ka. Aduna sumain to we have relation quite first alpha L and alpha A gi marakta leiba alpha L and alpha A gi marakta what is the relationship? So what is alpha A? You have dL square by L is equal to alpha A dt. So you can write this as twice L dl. So this is like twice L dl divided by L is equal to alpha A dt. So L ka kre duna 2 harga dl by dt. 2 dl by dt is equal to alpha A ka. So it implies alpha A is equal to 2 times of alpha L hayabra. Yung si se, ma'am. Kano tawriba, ma'am? Yariba? Alpha A is 2 times of alpha L ne is yaningbra yaningdabra. There seems to be a mistake. Where is L? Alpha L, alpha A dt. Adudi L ama what level ko? L ama zikai chakra. 2L dl level ko. L square is the kidoban differentiate or the 2L dl level ko. So dl by L dunti kenola kadenya ko. dl by L to alpha L ko. Sisi budi arba. Somewhere kind of normal mistake am lazy kain oh sigi sida ne L square legedaba dl square sida so L square legedaba ka aduna sigi sida dl ka I have to put one L here adu may wala me ka there has to be an L here so dl by L di kain no dl by L di alpha A ne ka duga by dt ka c sina kedaba 2 dl c sina alpha L ba ka adu dugin yani Yarbo me am sigize ngaubra since we have the net dl by L is equal to alpha L dt ne buka on dt je sompugre on dl by L dt di alpha L ne buka adu sumain tarpa yaribo me am
Yes, sir.
yarika Christina yaribo Sahila Sintoy Lakshmi Sunanda
Yes, sir.
okay ngangze yam kumung tisi kayino
NEET yaudaway kainom
NEET
tawgredi.
Okay, NEET yaudaway nebaka. Okay, now number 2 yung zika second subasina let's find the relationship between alpha kay hazika alpha L and alpha V yung puthose baka. Now alpha asigi sidi kamain to usige have the yung ka kuina kay khangi have the volume to the L cube ni sita so L cube lani is equal to alpha V dt le ni ka. Adu this is the thrice L square dl by harga sisina adum L cube adum lere aduga sida dt lere is equal to alpha V lere adu dc kaktat kra matungda 3 times of alpha L is equal to alpha V lere ka so sisima lere mathangda adu ibata argadi third subada kai lei hai matamda between alpha A and sisina ngatang thangdu ka alpha V hai tare ka so no this is uramgadra uramoidra je khangdre duna let me just switch off the video for a while and see ngatang minimize to thoke ba yaramani jikti so sisina muka kamain to guduino have the sigi se equation c1 harge and this is equation 2 harge ka auna from 1 and 2 harja natraga is direct 1 and 2 implies harja 1 and 2 implies harga nangisida alpha bz alpha v is equal to 3 times of alpha L the alpha A by 2 okay no is my interface alpha A by 2 hai tare ka sumaina thamasu yare ka so aduna therefore harga you may say alpha B is equal to 3 by 2 alpha A which is equal to 3 times of alpha L or you may even write 2 times of alpha V is equal to 3 times of alpha A is equal to 6 times of alpha L ka so C is uchumi or sigi su chumi ka ina apa mong thambe or c3 je makha la ga som du loina mong thamma je or you may even say 1 by 3 alpha v is equal to 1 by 2 alpha a is equal to alpha l and as my hash ya ka so si myam chi loina mak chumme ba yari ba myam ya de
Yeah, sure.
ya ka aduga sir wa ma hange ba ka nita kai chakre sine ba ka now Nazik sir na nui dine ngasi je hoi nui satra jo aroi bida yam dre nui tieng na sang na re ko internet ya tam ni khang de test har bai one of ni khang de ko da na sir gi jo internet ya de sir gi phone de data tha doi ne ba ko now sir na hining is kaino have the hazik aina tai ba po sigi significance kaino sir what is the physical significance of alpha l alpha a and alpha b have the sir si kaino sir tauri ji kaino mai kanab ji kaino har ga di real life significance ta mai kanab je du ki matik lay ko si khang raga de khoina pot ama sa matam da habdi especially civil engineer kangbu gai si khang da bsya de ko pot chei sa matam da railway track sa boy gera na tragana even yum sa boy gera ko thong sa boy gera lambi sa boy gera si gi coefficient of thermal expansion ji khang raga di heta sa ba de ko si kai adu noi adum ke do yeb da khoi gi manipur gi context noi myam na ko ai khang ga da ba kangla mamang da gi chat ki bada uripok ta taba noi gi ziki ke do ba flyover do khang bra myam
Khangi sir.
khangi ko koi manipur gi ni flyover ji ama khatang ni haji ki do khatang lei jai ko haji flyover bu di am kanna sa na ba tori ko ai di kena to ba sagol ban lambi ga do yam kanna haji to khai nan ko tan to ga kai do ba railway line ju lak pa gi ko so flyover adum sara ani hai tare ko athu matam da some I but I don't know athu bai ji kyam kui dino khang de 5 years sang be 10 years sang be but kedo wa ji sabadi hodi hore ko so flyover khara di la ani manipur da so ado hazik sarna si physics ki context la ji ko alpha l alpha a alpha v je si the coefficient of thermal expansion ji kyamuk maru ji noina adugi vertical ji flyover do kangla mamang deina uri pok ta ba ko adu flyover du da noi gari to ma chat pa yaw ba yaw re ko
Yaure.
gari to ma chat pa da gadak gadak law bra
Lao.
law bani ko lambi kai be na ta ba ai di mai flyover gi mai sorok to khara kai be wa na ta ba adum hantrik haling ai de dum gadrak gadrak law bane ba kai no thong do block oina sa bane ba makak ho bane ba thong do kyan ta right ja block wise set bane ba khale for example let's say I think my block to some around 15 meter mu ko ram gadra 10 meter or 15 meter le na le ani dra makak ama ho ni ba sang na adu another 10 to 15 meter adu another 10 to 15 meter ai 10 meter 15 meter di khang de but somewhere around 10 to 15 meter khudingi khotrong ho bane ba sang na thong do adu da noi notice to bra to da bra
호버드디 우디 그거 그no 가닥가닥 라우드디
khang ba
탱탱네.
adu theng nei ba ko
아,
adu gi gadra gadra law yu thong do ho bai ni aho ma pa ta
호버드.
khudingi ne ba putha boy kai bai ai tire du na aho ma pa ta ba khudingi ne ba ko keno to ri da noi da gadra gadra law yu gyan tai ko so adu du moina thawinki thamine ba ho li do ko adu kai do bagi thamino ha ba matam da concrete si kai do wi have the concrete we gira I don't know pot khuding mak se hit to matam da expand to we ba ko ana thong ji di laibang matak ta leiba na te ba sorok to or ga di mai expand to no ba jaga leiye ba now matak ta sa ba thong gum ba ji di kai do wi have da adu do hap ta ba ta ga di man expand to ko matam da thong du gi periphery oi ba magi circumference ki type ta mangon do hole to my frame do adu ne expand to ko matam da frame do pokhai rak pe chance yam leiye ba ko amna summer hot summer dm amada kai do kani have da adu gi araw do khara khuzan gani ba kai no di expand to pagi aduga winter no mitana khwai di winter gi for example let's say kai do we have the winter solstice ga 22nd December ka and 21st June akoi in northern hemisphere ni na ka ani ai di no na 21st June da no bane caliper am puraga ziki thong any block ani gi marak na apamba block ani khallo thangna ba adi marak tu gi gap to nang even bane caliper yaw to chum na gi normal scale ama puraga mai gap a hobo do all over hot summer day the nikon 21st June gi adum around pung tarama thoye dai da ko 11 am da kai gino sir na 11 sir 12 nun hai di je kai na akoi gi time zone je pung ama muk chon thai hai ta na akoi na ga sida pung baro pung pham ni phatte khote lightin thengna ba ka hai do akoi je manipur je india gi oina hai di time zone follow to ye ben india gi time zone ji di kai do ya matam da up da up gi kai ne mai mai keno maming de call gre ko exact magi keno maming do village maming do adu phawe baduna akoi gi pung baro je seng budi isagi time zone follow to jaba tar gadi north east ki or manipur gi time zone ama lei tar gadi pung ama je akoi gi hade akoi di pung ama tar kan da koina pung baro ne ko aduna adugi wani da yamna scientific oina changjal lagadi so pung tarama thoye dai da ko 21st June gi pung tarama thoye da noi barne caliper puraga kedoba BT flyover gi bir tiken resit flyover gi any block ani gi gap to all over adugo 22nd December gi nungdang la ayuk na tara all over kenani ba ziki lawi chang do yam tin kenani ba ko so adune ba aduna arau ai kitang gap tham da ya de ba expand tor kum matam da magi expand to no space ne ba koina tham bi je thongam sa matam da aduda yes sir adudi adum thong khuding ma adu loi hapam gadra adum lauram gadra har gadi kainoni ko akoina thong je yamna phajana sage har gadi haptaba ya de thong khuding ma ko adu haptaba thong ju myam thingnaramni ko aduga haziki dudi kaidu we have the koina swaina kitang curve hoina ju sare aduga curve oigera hapam di thokpane ba adu akoi gi civil engineer manipur gi civil engineer na calculation sise calculation change ba ko kay hani adumaina akoida nungai tabasi leidi le haloi dabani moina sumaina cross oina zigzag form daga hapazu yai expand tor kan ado zigzag form mak natragazu akoi manipur gi kay hani manipur gi kenoje 21st June da leiba ita ko northern hemisphere gi ni kwai saba no mineba sida leiba temperature duga akoi gi coefficient of thermal expansion of concrete haitare ko adu duga adu ani dugi akoina chang du puthoga o sifo expand to gadam ni habda adu du khot laga saram batar ga di koi gadrak gadrak law roi ba ko koina gap to kitang lawman greba adu maina law gadab na te gap to ko aduna adu aina si recorded class ina moina targa yamna keno to wena khallani but anyway fact is fact ko science is science so sabada soiri ni ko adu do koina gari thawda nungai tri do gap to kitang lawman greba ko adu gini anyway adu noina sarna hajik noida haining is adu gap to kai gino habda sigi akoina hajik nei nei topic coefficient of thermal expansion dine pot khuding maksi koina ke de habda heat tawda or temperature ji increase tawrpada expansion taweba ko so adu gi wanida yarba myam
Yare sir.
Yani sir.
yani ko seila yarbo sinthoi udagi lakshmi kedoba noi net yarbo
Yani sir.
okay
Yare sir.
lakshmi ga sunanda ga tai ko
Sir. Guys,
a participant has asked you to start AI companion. All participants will be able to access topics and content from this meeting. You can change access permission in the AI companion. AI companion start our own education. What is this?
Hoy bine sir, ay nani.
Okay. Nangnanewa ko. Soibaneva. All right. Yeah, sir. Correct ko. So may di ay yun na ngayon ko but test out din na sum kanging may tawon. Anyway, fine. Sila ko. Coefficient of thermal expansion lay mathang da kay lay noy ko. I would do hepet ying si ko. Measurement of temperature layer, then specific heat capacity and calorimetry layer ko. So measurement of temperature in Celsius and Fahrenheit. Yeah, okay, fine. And specific capacity ga measurement of temperature ga tawsalasi ko nasigidi adu ni lang toraga losalasi yam sang toros. So okay, basically measurement of temperature ka. Auna kedo we have the all right, let's do measurement of temperature. Now, measurement of temperature sida with we have the noina khangjin gadaba amna 0 degree Celsius si kai gamane have the 32 degree Fahrenheit gamane ko NCC kai not to 73.15 Kelvin gamane ko, and then 100 degrees Celsius si 212 degree Fahrenheit gamane NCC 373.15 Kelvin gamane khangnabra si se hanadagi ma'am
Khangye sir.
khangi ko
Khangye sir.
khangi ko ataidi again no response. Sunanda khangbra hanadagi Lakshmi Anjali.
Sir, khangye sir.
So aduna kaido we have the ko kari azik akoina temperature conversion gi ko formula ma sir derive toge ko yo graph mi ke duga kaidi torji gi 0 then phala 0 degree Celsius ka. Okay, fine, so main torge ko yeah. So let's say 0 degree Celsius to 32 degree Fahrenheit. So assume na Fahrenheit le hela 0. Do not further one ka. 1 second. Sumain jalan je. Sida set pa na fade ka. Okay, fine. Yeah. So now let's mark the points. This is 0 degree Celsius. And let's say somewhere here, this is 100 degree Celsius ka. And here, let's say, this is the 32 degree Fahrenheit. And let's say somewhere here, we have 212 degree Fahrenheit. Yare ka. So, kaido we have matam the queen graph C, sidagi, laka din yung buka, sumayin sum chat laga, laga C orni, si mapa sidagi, sumayin chat laga, si mapa si yogo din yung buka, ay C 100 degrees Celsius C. So, you can see below to pe other. Si thamage ka, sumayin le. Alright, fine ka. So, sige, coordinates si kay lakani have the yang as ka. Let's find the coordinates of this point. So, sige coordinates si kayo when you have the 100 degrees Celsius and 212 degree Fahrenheit. Sige na coordinates si kayo ni 0 degree Celsius and 32 degree Fahrenheit. And somewhere so either in a point P go wam sa le magi coordinates si kayo ni have the x degree Celsius and y degree Fahrenheit. So now I a straight line ko. So C straight line is in I can convert any temperature in Celsius to Fahrenheit and any temperature given in Fahrenheit to Celsius to convert to So kamain to do know haragadi, let me derive the formula here. It's a what is wrong? Okay, here I go. Now let's try to convert it. Sir, mind to uzi abrium ko ma'am 212 minus 32 divided by 100 minus 0 y minus 32 by x minus 0. Yabra sige se? Yung ma'am? Yeah, de.
Yes sir.
No response.
Kumme sir.
Nati, oh, kumme buka. Okay, fine. Sorry, anyway, fine, yeah, so aduna no si kang bataragadi kada we have the y minus 32 is equal to 180 by 100 times x layer ni buka. No si further solve to we haragadi it implies y is equal to haraga 2918 to 510 9 by 5 haraga x degree Celsius plus 32 nebako. Y is y is in Fahrenheit nebako. Auna y sinin nang Fahrenheit ta pamagadi y degree Fahrenheit is equal to, you have somewhat like this haitare ka. Sisima khangjallo. Similarly, sidagi kay layni hai matamda x by y minus 32 is equal to 100 by 180 nebaka. Aduna, you may say x degree Celsius is equal to 5 by 9 haraga y degree Fahrenheit minus 32 haitare ka. So sumailani. So you get this formula. Now let's try to use this formula. Sigi formula ni si ko use to question kara solve to zeba. Now let's say question da convert Roman number 1 da let's say akoigi human body temperature 37 degrees Celsius to degree Fahrenheit, and Roman number 2 dana let's say room temperature se ka. Room temperature से Fahrenheit क्या ले खंगब्रा खंगदब्रा खंगदे room temperature से Fahrenheit क्या ले मैं इस खंगदे बको नाइको. What is
98.6.
hey
98.6.
98.60 room temperature ना ती body temperature ने तो ती
Body temperature
68 degree Fahrenheit to degree Celsius higher से बको. So असीगे नहीं तो उसी का. Now do it better the first किसे तो और सी Roman number 1 से 37 degree Celsius से degree Fahrenheit तो उनको क्या है गदी सीधे पाला नहीं का. Now y degree Fahrenheit is equal to हर के दोबा 9 by 5 into x degree Celsius से कहीं 37 ले का plus 32 तो वो दोने बा. So CCD कहीं ना कहीं दोने have the 9 7 63 9 3 20 के 7 27 plus 60 कहीं तारनी have the 30 के 3 ताबरा का divided by dum sumain tawrage asida okay yeah dollars by 5 plus 32 ay tare ka audi ke doni have the 5 6 30 amukazu 5 6 30 aduga di amukazu 5 6 30 ka plus 32 audi sidi kai tarni 678 98.6 degree Fahrenheit ka aduna khoigi normal body temperature is 98.6 degree Fahrenheit tabane ba ado koina fever leire ka hajen sigi 98.6 da kitang bu hengala ba noi 99 100 ka yor ba ado de ko fever lei ba hore 101 sizu yam kan ba fever ni ko 103 ga yor ga di body da mai di ado ki mati kanman gi da mi na yang ching ba ka haje 103 ga yor ga ne keno to is angang hai ti ching keno to bu ka hena bu do ching ba ka hena bu do na yam kan na ka hena ko kan ba fever oira ni du gi ko gyan ta bro myam si gi je
Tahawi sir.
Okay, sir.
oi ko mathang da Roman 2 je muk try to si Roman number 2 je 68 degree Fahrenheit degree Celsius to puto har ga di x degree Celsius is equal to is 5 by 9 times harga 68 minus 32 ay tare. So aduga degree adum degree Celsius ta zarani ka nang kon hapsalage adur ga city kain have the 5 by 9 into 8 minus 2 is 6 and 3 ka 36. So 9 4 36 and this is 20 degree Celsius tare ka. And koi room temperature je 68 degree Fahrenheit ne ba average room temperature je adu do ke the Celsius tana 20 oidana 20 to 25 oigali dana ko room temperature je khang manatro
Khangi.
Okay, sir.
khang ko khang ni ko khang budi na te ko hana dagi khangak panatra. Okay, fine. Alright, so yare aduna measurement of temperature aduna ke do we have that no the any temperature se adagi ne kano the Kelvin the change to budi haigadra Kelvin the change to budi degree Celsius to layer di kem to ngai late 100 sorry 273.15 plus option ga do ko aduga kaigumba Fahrenheit le amana Fahrenheit Celsius to onto matungda 273.15 plus option ga do gyan taita de
Tai, sir.
tai ko adumain to adum convert to yare aduna sigi formula se aduki matik maru oi ko si formula ni se aduki matik maru oi ko si ni si khangadam ne ko si khangda ya de du dum si na tarani mathang da heat capacity se ni ngasi tak thoga di medium de tak thozira tak thoge ko haifet adum tak pa horage natraga ni ngasi gi class de yamna maru oi bisi kashu thoi do pa yaw da ta aduna heat capacity target ka okay fine let's do direct heat capacity in our okay fine heat capacity adi kaino Anjali khangra
Hadi maze hit neba hadi 1 degree Celsius ama hinkat hotnaba changiba amount of heat.
very good the amount of heat required to raise the temperature of a body or substance by 1 degree Celsius. Now, heat capacity of 1 liter of water and heat capacity of half liter of water is chamanagadra or kenagadra. Si sarnahangi si kenodani ko mayam loy namaktani ko Sunanda, Lakshmi, Sintoy, Sahila, Christina, Anjali, Tabra. Heat capacity is hazikta Angelina hai chumme bako. Heat capacity is the amount of heat required to raise the temperature of a body by 1 degree Celsius. So, body amagi temperature si whatever my layer temperature to the 1 degree Celsius hengarhan gyar gadi heat credi pishan they are idana. Adugi amount of heat required to be heat capacity ka webako. Now, sir naji hangisina half liter of water ga 1 liter of water ga heat capacity managadra manaroidra. Manani manaroi. Nyo jikta di kum gramale taudre to seeing the chappe. Managadro manaroidro. Kaino kanam ko muktijibo. Anjali Tabra, Christina, Sahila, Sunanda, Lakshmi Tabra.
Tai, sir.
Heat capacity half liter ga 1 liter ga manadiro manaroidro. Manado male. Ataydi ajikta kano kumge torame. Christina kumge torame ajikta do kumakitra.
Khangdaba sir do
Khangdebu ko. Sunanda di Tabra, Sunanda, Lakshmi.
Tai,
Taibu ko. Kaiba heat capacity je khangbra bahana. Khangyebu ko. Okay, fine. So heat capacity is half liter of water ga 1 liter of water ga managadra kenagadra.
Manaroi.
Manaroi ko. Lakshmi ga Sunanda ga di. Kay nui kumak trito is. Net nungai tabay ro kayo nito is ba? Sintoy di. Manado malebo ka. Okay, fine. Sintoy di. Sintoy tabra. Class nui kumak tramin anta kaya nito ka. Anyway, fine. Heat capacity have the amount of heat required to raise the temperature of a substance or body by 1 degree Celsius nebo ka. Aduna heat capacity di manaroi ba ka. Kay do manaroi di no have nang ising half liter khatanga 1 liter ga 1 degree raise toge haragadi 1 liter dun hen changoidro abidi ising jinangna kedoba ising glass ama sahan baga ising ketli am sahan baga ketli ama sahan budun hen changoidro abidi sanabun ama sahan bane hen changoidro adwain tawduna nangi ngasai amount to hengalai gai abidi the quantity of water or the quantity of substance hengalai gai kedone more heat will be required ne ko auna kedowi hamatamda heat capacity is a manaroi ko. So heat capacity it is the heat required to raise the temperature of a body by 1 degree Celsius. And my formula is in capital S is equal to delta Q divided by delta T. And then we have specific heat capacity. Now, specific heat capacity is the regardless of the amount. Magi have the per unit mass heat capacity per unit mass. My small s is equal to capital S by M Therefore, small s is equal to 1 by M, or let's say 1 by M. Again. Delta Q by M delta T. This is known as specific heat capacity. Yaradra? No response.
Yani, sir.
Yani ka? Okay, fine. So, sumaina layib ko. Aduna, specific heat capacity is the nangna half liter logera, 1 milliliter logera, 1 drop logera, 1 have the 1 metric ton logera ka. Have the whatever 1000 liter logera, any nang loaning by amount lozo specific capacity chap manani. Kay di nangna we have matamda nangna quantities am lokum matamda hit to the hit chang budi hengala kaneva. But adugi hengalaiba quantity do nong yen to kandadi. Ultimately, the result will remain the same. Aduna specific heat capacity is constant for a particular substance. Aduna water specific heat capacity but water heat capacity hargadi adudi question je complete aina for example noida hangeba for example let's say sinthoi water heat capacity kya no hangagadi sinthoi nengonda hangtuji sir question do complete water kya am low do no hangkatabneba for example sir ne sunanda water specific heat capacity kya no hangagadi specific heat capacity di constant neba ko my value ma lay neba but heat capacity specific pandabida heat capacity dang high wire gadi question do complete amount kya am low do no quantity kya am low do no na do la ka do neba sir na hining is kyan tabra no response.
Sure.
So adumain lay ko heat capacity and specific heat capacity ko. So anyway, fine ngasi this ibog torzin ko hayeng pazina continue torzin no chang nine pazina yauro aduga ngasi di question hot track ko sigi sir na ngasi tai ba topic kharsa pazina gyan ta na ko kaya toro Reynolds number tore thermal properties of matter hore the GC relationship to measurement of temperature and heat capacity and specific capacity ko hayeng si sigi chapter ji loina ba tak ka doini sir na ko aduna class yauro ko. Okay, fine. So all right ma'am, thank you everyone ko adudi ngasi class si kaya to ji ko ngasi gi di ko so idolo siya ji ko.
Oh, sir.
Okay.
Good night, sir.
Okay.
Thank you, sir.
Good night everyone. Thank you for the class. Let's call off for the day. Good night.